this well-defined and ill-defined, this thing okay, there are some other things that need to be talked about here. The statement that I wrote here, that ill-defined, that collection of symbols and numbers, that is easy to spot that it is ill-defined, but sometimes it is more subtle. For example, this statement, this is not a statement, this is an ill-defined statement, because in mathematics we cannot divide by 0. Why? I will come to that later. I will tell you exactly why we cannot divide by 0 and why it creates problems. This is an ill-defined mathematical statement. Now, if it contains some variable, for example, x divided by y is equal to z, this will not be a well-defined statement unless you also mention that y is not equal to 0. Remember, x plus 2 equal to 3. You cannot say it's true or false. It depends on x. Similarly, in this case, even the whether it is a statement or not, that depends on y. If y can become 0, then in that case it may not be, it will be ill-defined. So we have to be very careful in writing mathematical statements to make sure that this type of things do not occur. In fact, you may have come across some mathematical fallacies, some proof that 1 is equal to 2. Now, in most of these type of proofs, there are ill-defined statements. So let us actually go through one such proof of 1 equal to 2 and see where there is a mistake. So let us just lighten the mood with a fun wrong proof. So let A be equal to B. Okay. So I am considering two variables A and B which are equal. Now I can multiply both sides by A, so that gives me A square is equal to AB. Okay, I can multiply both sides by A. Now I can subtract B square from both sides. This from school algebra we get this is equal to A plus B times A minus B. And if you take B common out, because there is B in both the terms, then we get A minus B, B times A minus B. Now because we have A minus B on both sides, we cancel them out, and that leaves us with A plus B is equal to B. But we know that A is equal to B. So writing B in place of A, we get B plus B is equal to B. So this implies 2B is equal to B. Now cancelling out B from both sides, we get 2 is equal to 1. Now this proof of course is wrong, and I think you already know why it is wrong, but still we have to go through the things. Okay, so first of all, see, this is our hypothesis and we are carrying out mathematical steps. A is equal to B, A square is equal to AB. We can multiply both sides by A, that is permitted. Okay, there is no problem with that. So far it is okay. And we can also subtract the same number from both sides. The result will be equal. If the thing with which we started are equal, then subtracting the same number from both sides gives us equal quantities. So a square minus b square is equal to ab minus b square. This is also okay. There is also no mistake in this formula. A square minus b square is indeed equal to a plus b times a minus b. That is always true. Here also there is no mistake. The next step, however, is achieved by cancelling out a minus b from both sides. Is this permitted? This is not permitted. Why? Because since a is equal to b, a minus b is equal to 0. And we do cancel out things from both sides when they are non-zero. I mean, this is only an aid to our memory. I mean, it is a way of memorizing the final conclusion when we have similar terms on both sides of an equation. For example, if you have xy is equal to zy, and you know that y is not equal to 0, you write x is equal to z. But why? What is the reason that y can be cancelled from both sides? That has to be in your mind. If you have just simply memorized the